So here we are with the 1-7, these are the day 1 notes, where we are taking a look at solving equations in one variable that contain absolute value expressions. So those vertical lines next to something. Here's our definition. We should recall that absolute value of a number is that number's distance from 0. So in that case, if you have this here, the statement is saying how far is -5 from 0. And since distance is always positive, because if we do like a negative idea, you would just give like a cardinal direction, like north or south or east or west. Anyway, distance is always positive, and so in that case, that's why we always have this +5 as the answer. So a lot of people will confuse this and say opposites, and absolute value is not opposite. Oops, tried to make a U and an S at the same time. Okay, so again, absolute value is not just opposite. It's actually the distance that point has until it gets to 0. And so if we look at a number line here, we're just saying if this was the point, -5, how what is the distance? And that's 5 spaces to get to 0. So to write the statement using algebra, you would write this as its first, and then you're asking yourself what values of x have an absolute value of 5. And the solutions are both 5 and -5, and so you're going to have 2 solutions. Alright, so here it is in our kind of math terminology. So all it's saying in words is what we have in the previous slide. And then over here with numbers, notice that we have the 2 answers. Alright, and then visually, this is our visual graph, kind of number line idea. If you have a value of a, if it's -a or +a, the distance is just a to get to 0. So in order to solve this, because of course we're in our solving chapter, we're going to end up having something like this statement up here, where absolute value of x equals a, or absolute value of x equals 5, and we're going to have to solve it. So there's going to be something like 5 plus 4, or whatever. So we're going to use inverse operations first, in our first step, to isolate the absolute value expression. Okay, so we're going to isolate the absolute value versus just the variable, like we did in our last lesson. Then we're going to rewrite the resulting equation in 2 cases, because remember, when we were talking about it up here, there are 2 solutions, and so they're also called cases. Because, for instance, in one case it could be -5, and in one case it could be 5. So either way. Alright. Then, after that, we solve the equation as if it was 2 separate problems, so just regular solving. So, of course, we'll try this out. So, taking a look at the first one, remember we're isolating the absolute value. So, this entire piece, anything that's inside of the absolute value, that is one thing that we're trying to get all by itself. So, in order to get away from that green circle, we need to add a 3 to move it to the other side, so that the green circle is all by itself. What's left over is just the absolute value of x and the fact that it should equal 7. So we're trying to say what absolute value could I put into this absolute value and get a +7 back out. And there are 2, and this is when the case has happened. So in order to get the 2 cases, for case 1, you would set the original equation, which is x without the absolute value, equal to 7. And in case 2, you would set, again, the no absolute value equation equal to the negative of your answer. So -7. So both of these are our answers. Having 2 answers is not unlike what we've seen before. We've even had answers where there's infinite solutions. Alright, so moving on to the next one. Kind of the same idea, but as you can see, the absolute value is already isolated. So this is when we just get to break it into its cases. So again, in the first case, we're taking no absolute values, so just x minus 2.5, and the fact that it equals 8, that's your case 1. And then your case 2 has negative 8. Okay, so the opposite of that, equal to, again, the equation without absolute values. And so hopefully now you can see that all we would do is solve as we would any other equation and add 2.5 to both sides on this one. So adding 2.5 makes 10.5. And then over here we'd, again, same process, add 2.5, but of course we're adding it to a different number. So don't just tell me it's positive 10.5 and negative 10.5, because it's not. It's actually negative 5.5. So you always want to actually do the steps to find the answer instead of just saying, oh, I'll just skip half of it and say it's the opposite of what I already got. Because that's not always going to happen like it did up above. Alright, and then we have our last example, again, trying to isolate this absolute value set. You can kind of imagine it as parentheses. But of course they're fancy parentheses that actually mean make whatever it is inside of there a positive distance. And so this is 3 times x plus 7. And so if we know that that's 3 times x plus 7, how would we get that 3 away from the absolute value? Because remember, we're trying to isolate it. To get it away, you're going to end up dividing both sides by that value. If we divide both sides by 3, we're left with our official isolation of the absolute value, and then 24 divided by 3 is 8. Then we get to break it into our two cases. And so in case 1, again, no absolute value, we're going to take x plus 7 and set it equal to 8. And then we're going to set x plus 7 equal to negative 8. So to solve, we will subtract 7 here and get an x of 1 as one of our answers. And then subtract 7 here and not get negative 1, but get x equals negative 15. So again, it's not always just opposites. So the process is isolate your absolute value signs. Once you get your absolute value signs alone, break it into the cases of positive and negative. And then once you break it into positive and negative, solve like we have in the previous section. So we do want to be sure that we check both solutions when we solve, because basically there's no way that you can get this wrong as long as you check. So for instance, if I take this negative 15 and plug it back in, I'm going to have 3 times the absolute value of negative 15 plus 7, and we're seeing if that equals 24. So we take negative 15 plus 7 and we get 8. And 8 itself is going to be absolute value, and that's just 8 again. And 3 times 8 ends up being 24, and of course 24 is 24, so hey, it worked. So again, the only thing that you would do is double check your answer, especially if it feels like it didn't work out. You can always just plug it back in and see if it worked. Alright, so that's the end of the 1-7 notes, and those are the types of problems that you will see on the 1-7 Day 1 assignment.